In this tutorial, I will explain to you what is the code candidate genes and how to use it. So candidate genes.m was written in MATLAB, and its aim is to analyze survival, to do survival analysis on gene expressions of cancer patients. All right. So first, in this particular tutorial, I will explain where the dataset comes from. So our dataset comes from a site called cbioportal.org. Okay, and this is a cancer dataset. All right, and when we will look for example, a certain cancer, like breast cancer, and you and try to search for a dataset that has many patients in it. For example, this dataset, which I already downloaded, and oops, we need to find again, to search again. All right. Or this dataset. And in order to download, please look for this symbol. Now, we can work with other datasets, not just from cbioportal. In the beginning, I didn't even know that the data that I got was from cbioportal, and I did made it so you can have a different type of data set, for example, a certain standard that we decide in the lab. And the problem with the fact that I didn't know that the datasets all came from cbioportal is that in the beginning I tried to find common similarities and construct my code from there, and otherwise I would have written my code differently and less cumbersome. But this is what we have, and yeah, let's go and look at where our files are. Okay, so I downloaded two datasets beforehand, and let's look at the first dataset that I downloaded. And the problem with this dataset is that I don't have a particular file that I'm looking for, and the particular file is a gene expression data, and I don't see that here. Okay, I have clinical data, I have CNA data, mutations data, but I don't have gene expression data. And the meta.txt files are usually files which provide info regarding what we have, or where from which study the data was taken from. So let's look at a good data set. And here So here is the gene expression table that we are looking for. We are looking for 3 tables: a gene expression table, a clinical table, and a mutations table. While we can deal without a mutation table, we do need at least a gene expression table and a clinical table. Okay, so let's open it. And usually the gene expression table will be called mRNA, median, and it will be normalized. So let's open it, and let's open it with Excel. It's a big file, so it would take time. Now, most cancers don't have enough patients. I would say that breast cancer is one of the biggest data sets, even though 2,000 patients is not such a big data set. I don't know, maybe lung cancer would have more because it's a common cancer, but lymphoma or sarcoma or germ cell tumor definitely have less number of patients. Still opening. All right. Yes, this is the file I was looking for. Okay, so what you see here, you see a row with the name of the patients, the ID of the patients, and the gene names. We have 2 columns that describe the gene names. One is based according to the Hugo symbol nomenclature, and the other one is the entrance gene nomenclature. Now, we can work with both either or both of either one of them, but my code was mainly tested on the Hugo symbol. Okay, and these are normalized expressions of mRNA, which were taken from cancer biopsies of the patients. Now, what you want to look for is your main driver gene. Driver gene is a gene where accumulation of mutations in it might cause cancer. Okay, so let's look for this driver gene. And no, this is not what we are looking for. We are looking for the exact name of this gene. That's not it. Aha, we have it. That's good. Now let's look for another driver gene, MET, and it exists. Now let's look for. Okay, so all the 3 main driver genes exist in this table, and that's good. I was questioned regarding the minus symbols, and you have to understand that the expression was normalized such that the median would be 0 and the standard deviation would be 1. And I think it was normalized per row, but I'll have to make sure of that. I don't know if it was per patient or per row. Okay, so and you have to save the file as an Excel file. I'll show that with the next table that we look for, and this is the clinical table. Let's open it again with Excel, and that's a good clinical table. And as you can see here, we have the patient's IDs. Now, the patient's IDs, it's the clinical table and the gene expression table both have the same patients, yeah. But sometimes there are more patients in the clinical table or the gene expression table, and so so even though you might see that this data set has 2,509 patients, well, if you intersect both of the tables, and you need this intersection, then you will have less number of patients. And I think in the breast cancer case, it's about 1,900 patients. And so yeah, be aware of that. And try to find as many patients as possible. Okay, so what we're looking for, you have to search for certain columns. You have to search for a column that's called overall survival status, which basically is a column that describes whether the patient lives or whether they're dead or alive. And the overall survival status is decided or is written as if from the first diagnosis of the patient until they finish their follow-up or they die. You also have this column. You don't need to find it, but I think it's the only column that I've seen in like that describes a living, died of disease, and you have also died of other causes. I think in the breast cancer dataset, the breast cancer dataset is the only one that has this column, at least from what I've seen thus far. Another important column is overall survival in months. For example, this person has survived more than 10 years, even more. Hey, more than 11. And while this person who is also dead also survived about 8 months. Okay, and another thing that you have to pay attention to. You have to pay attention to the ending of these two columns. And wait. Okay, yeah, so the file continues, even though not everything was documented. But you have to make sure that these two columns are equal in length. And by that I mean is that you have to make sure that the cells in the last row are filled. I can deal with mutation data in either cell, in either column. but I cannot deal with missing data in the last row. It's something that MATLAB cannot overcome this because it guesses the last row. Just so make sure of that. And this is important because there have been cases that it was not the case. Okay, so another column that you'll have to look for, but it's not a must because my code doesn't deal with it yet, is the subcancer types. Not all cancers have data regarding these subtypes. Oh, here it is. So the column will be usually called a Claudine subtype. Again, my code, it has to be rewritten in order to work with that. So just know that there is a possibility to look for this column, but overall, thus far we are not dealing with this. But overall survival in months and overall survival status are important. Oh yeah, and sometimes it's overall survival in days and not months, so it's also something to pay attention to. Oh, and I forgot to save the file as an Excel file, but we will do that with our lost data. Okay, and this is the mutations data, and it looks like this. Okay, so here we have gene names. Whoa. You have gene names. What is going on? Never mind that. Yeah, anyway, so you have the gene names. Not all patients were sequenced, yeah, and so you have a column of the type, for example, of the tumor, and you need to look for the column that has the column that is called tumor sample barcode, usually, which basically is the patient's IDs. Okay, and now here's the thing. The mutation table is quite small, at least in comparison to the other tables. So you might not find your desired gene, and you might not get results. And for example, let's look for MET, and we don't have MET here. So if you don't get any results for my code, I write while the code is running. I write, oh, no gene was found. So I do deal with it, but you have to understand that just don't be surprised if you don't get any results. Just know the reason, okay? Oh, and I didn't save the file, so let's just show an example on saving the file. Let's save as, and you need to save the file as an Excel file, XLSX. Okay, and okay, so in this tutorial I talked about what are the data sets and what is the data that we work with in the candidate genes code. And I wanted to show that it's not a black box. And also, you might not need to actually find new data sets because we already have data sets that we downloaded in the lab. And the code points to these data sets. And these data sets are found in Metal 26, D, users, Hila, Shaham, candidate genes, and DB for your human analysis. And this data set is separated based on cancer type. For example, let's look at the germ cell. And you have several data sets, but not all of them are good. So in order to look for which data set is good, you look at the meta info, and you have there, for example, germ cell tumors. This particular study does not include gene expression table, so that's not good. But this study does, so that's good. All right, so that's it for now. And during the next tutorial, I will teach you how to create a short version of the gene expression table that will only include your candidate genes, your desired genes. Yeah, that's it. Goodbye for now.